Welcome to our lesson on activity 4.1.2 part B. It's the second part of the lesson on cams. This lesson is going to focus on parametric modeling, and just in case anybody is confused or just curious, yes, there is a cat tree in the room in back of me, and there is a cat sleeping on it. He might, who knows what he's going to do. He might get up and move. But yeah, so I have a bunch of furniture in the middle of the room in back of me. It is what it is. All right, on with our lesson on parametric modeling. So first up, what are your deliverables? What are you going to need to produce at the end of this lesson? So at the end of this lesson, you are going to model a cam using parametric modeling. So you're going to demonstrate that you can generate a CAD drawing that has been done or design that has been done parametrically. And then you're going to create a screencast showing how the parametric modeling works. So there's two main things that you need to keep in mind as we go through this lesson. One, you want to really understand what parametric modeling is. Okay, how does it function? Why is this a useful thing? And then demonstrate that you can work with it so that you are able to design something using this strategy and show how that strategy works. So there's more details at the end of this presentation on exactly what your screencast is going to have to include. But that's what you want to keep in mind at the beginning of our lesson here. So what is the concept behind parametric modeling? One of the goals of this lesson is to understand what parametric modeling is. Now, our CAD programs are already parametric. If that sounds a little bit familiar to you, like I think we've talked about this before, it's probably because we have. If you were to go back in the curriculum somewhere, we referenced the idea that Onshape, Fusion, Inventor, a lot of our CAD systems are already parametric. So what that means is that some features are dependent on others. So as you're going through your design, you use existing sketch entities or features or bodies to design the ones that come after it. Now, this is why when we go back in the browser or the timeline to edit a sketch, any extrudes or fillets based on that sketch automatically update. Okay, so for example, if you designed a cam, we'll go ahead, we'll draw on this a little bit. So you designed a cam, let's make it a hex cam, okay? And you put a hole in your hex cam. And then you realized that that hole was too small. So you did the whole 3D model, maybe you even had me 3D print it without checking it, okay? And then you go to put your axle in your hole for your cam and the hole is too small. And so what you would do is go back in your timeline, you'd click Edit Sketch, and you would take the sketch of that hole and you would make it bigger. You would make that adjustment. When you accept that sketch, everything else in that model is going to update. So you don't have to go back and update the extrude. You don't have to go update anything else about it. Go back, update the sketch, and the rest of the model will update with it. Now, sometimes the CAD programs will send us these like red flags and errors. So sometimes you have a feature that's dependent on an earlier thing. And when you go back and change that earlier thing, you actually create an impossible situation. So for example, if you had, say, we'll use, I've got like a chord here, okay? You want to make this chord and you want to sweep it. Now, suppose your sweep has it really, really tight, okay? And then you're like, well, wait a minute, I want to go and I want to sweep a much wider wire. If you make it too wide, what's going to happen is these two sides are going to start to like collide into each other. Like there's only so much space I have to work with. And so when that happens, the CAD program might error on you and say, hey, you can't actually change the profile to make it that big because now it's going to wrap around into itself. We've also seen parametric features in play when we use geometric constraints. So if you think back to our lesson on constraining sketches geometrically, what we're doing there is we're defining how two sketch entities are related, but not always their specific dimensions. We define the relationship between them. And that's what's really, really key to parametric modeling. So here's an example from an earlier design. I forget what this is from. It's from some kind of like widgety thing that we did much earlier on, I think, when we were learning how to fill it. But in that design, we had to do a square. So if you look at these two squares, okay, these two squares are identical. Okay, they are identical squares for all intents and purposes, but they have been designed differently. Okay, so they've been, so just like we're talking about like parametric modeling, these two squares, while identical, have been designed different ways. So the one on the left has both dimensions as 2 inches. That's how we know it's a square. So I drew the rectangle. I dimensioned this to be 2 inches. I dimensioned this to be 2 inches. We're done with our square. We have a 2 by 2 square there. The one on the right only has 1 dimension done, which is like pretty obvious, and an equal constraint applied between the two sides. So right here and here, you will see the little equal constraint symbol. And what that means is that this side is not defined by its own dimension. It is defined in its relationship to this side over here. And so this side is defined as being equal. So in this square, I only need to dimension 1 of the sides, and then the other one, because it's constrained to be equal, will automatically be the same size. So why does that matter? Well, maybe it doesn't, but if I want to change the size of the square, the one on the left needs 2 dimensions changed. So I actually need to go and change this one. Let's say I want a 3 by 3 square. I have to change this dimension to 3, which is going to give me a tall, skinny rectangle for a moment. And then I'd have to change this one to 3, which would revert it to a square. The one on the right only needs me to change 1 dimension. And so I can just change this one to a 3, and then because of that equal constraint, that the other side will automatically update with it. Now, one design is not better than another. It goes back to design intent and what you're trying to do. If you know for 100% certain that you are going to want a square, then this is probably the better way to do it. If there's any chance that you might not want a square, that you might want some other kind of rectangle, then you don't want to have that constraint on there, because then you'd have to go and remove that constraint in order to be able to change the shape there. Okay, so this isn't about one design method being better than another design method. It's just about knowing what your options are and thinking ahead to how to make your design better and more efficient. So this gives you the idea behind what it means to be parametrically modeled. So we can build on this idea. Geometric constraints build parametric features into our design based on geometric relationships, such as equal, which in geometry class you'd probably say congruent, parallel, tangent, and so forth. So you define the relationship between the things in your sketch without necessarily defining every single dimension or plotting it on the coordinate plane. So you might just fix or constrain one point to the origin, and then you build around that. You don't fix every single point. And so we use that all the time, and hopefully you've gotten more comfortable with the idea of constraints. Now, suppose we wanted one side of a rectangle to always be 1/4 the length of the other side. We can't do that with a geometric constraint. There's no geometric constraint that says make it this side 1/4 the length of the other side. I can constrain them to be congruent because that's a geometric relationship, but not 1/4 of. So we can't do it with our geometry, but we can do it with our algebra. In other words, we can do it with an equation. Okay, so this is where we kind of move our math of the design from the geometry over to the algebra. So we're going to go from, hey, make these congruent, to let's define an equation. So for example, we can define the width of our rectangle to be L divided by 4. So instead of putting in our own separate dimension, Okay, think back to the square where you have to do both of them separately. We can take one of those dimensions and define it using an equation in terms of the other dimension. So what happens then is if we change the L value, the W will automatically change with it. So if L is 8, W will be 2. If L is 4, W will be 1. And we don't have to go back in and change those relationships. Now, again, this is something that you would want to do if you knew that you wanted a particular relationship to hold. So again, like the idea of scaling things, making things bigger or making things smaller, if you want all the proportions to be the same, you can define your dimensions parametrically, and then one little keystroke can make your design bigger or smaller in the way that you want it to be made bigger or smaller. Now, one thing I like about Fusion, and this screen grab came out of Fusion here, is if you see the little FX in the dimensions, then you know something has been parametrically modeled. So looking at this particular sketch, what you can tell by that is that I did not go in and type in, hey, this is 1 inch. I did not do that. Now, you don't know what I did without clicking on it and getting more information, but you know that this dimension here is dependent on something else that's in my design. Now, since we have the 4 here and we're sitting on this slide, you can probably conclude that this is like, well, that it's the length divided by 4, because that's what we had over here. So I probably did the same thing. But if you didn't know that, I mean, it could be the length divided by 4. It could be the length minus 3. All right. If you think to your algebra studies, you can't just have one point like, hey, take a 4, make it a 1, and know what the relationship is. You have to have more than one point. Okay, so that is the idea behind it. If you need to, pause the video and just kind of let this sink in, what we're doing there. So what we have here are some examples of what a parametrically defined sketch might look like. So you might define one key dimension, and then all other dimensions are defined in relation to that one. So I think what happened here is, I think I stretched this when I put it on the slide, like I wanted the figure to fit the slide. I think this is supposed to be a circle, but it looks a little stretched, but assume it's a circle, okay? So what you might do in designing your cam is you might have your diameter, and this is going to be that one key dimension. And then the distance between the hole and the center of the circle, you always want that distance to be 1/4 of the diameter of the cam. Okay, and so if you go and change the diameter, then that other dimension is going to change with it. So if the diameter is 2, then that would be 2 inches, that would be 1/2 inch. If the diameter was 1, then that would be 1/4 inch, and you're going to get that changing accordingly. Then you could do, design a bunch. We have a bunch of stuff here with different kinds of cams where you might change your D value, and then all of these other dimensions will change according to that relationship. You can see where this could save you a ton of time. So if you know what those relationships are, then you just have to go back and change that key dimension, and all of your other dimensions will update with it. Now, a lot of times when you're designing something, you don't necessarily know that, or you don't have that kind of flexibility. Again, this is just one of those tools, one of those ways of modeling that we want to add into our repertoire. So how do we go about doing it now that we know what it is? So this is a class exercise demonstration. I actually recorded a video that goes along with this. So if you fall behind or you're making this up at home, please go ahead and access that video. So there are different ways that you can access the parametric modeling features of CAD systems. And what I decided to do in the development of this lesson was to try to keep it as simple as possible. So I kind of went with, let's build the the modeling in as we're doing the design, but you can also take an existing design and pull up a table and make it parametric after the fact. So in your CAD program, start by sketching a rectangle. That's going to be true regardless of what CAD program you're in. In Fusion, when you go to dimension the length, I would like you to just type in L equals 5. So normally we would just type in 5. But we're going to type in L equals 5. And what that's going to do is it's going to assign a variable to the length of the rectangle. It's going to assign that to be L. Now in Onshape, you have to type the pound symbol or hashtag, okay? I usually say pound though. So the pound symbol and then L, and then there's an option that pops up that says create new variable. And you're going to pick that, and you're going to pick the new variable, and then you're going to assign that variable to be 5. If that is confusing and you're doing this from home, please go look at the demo video and you'll see how I do it. Then dimension the width of the rectangle to be 2 times L divided by 3. So this is a situation where we would like the width to be 2/3 of the length. Make sure that you use the pound symbol in Onshape. So you want to do 2 times, and then Onshape really looks for that pound, okay? Like looks for that value, and then the divided by 3. Go back and change the value of L several times to observe how the other dimension changes with it. In Fusion, you can change the value of L just by clicking on the rectangle and changing the dimension. In Onshape, over in the browser on the left-hand side, you'll see the variable pop up in that browser, and you can right-click on that to edit it. In the video, it like errored on me really strangely, and I paused the video and then literally did nothing different, and then it worked. So okay, and then extrude the rectangle to make a prism, and we're going to do this with a subtraction. So we're going to extrude it to a depth of L-1, and remember, if you're in Onshape, you want to use like pound L-1. And the point of that is to notice that you can use like multiplication, addition, like anything that you could put in an equation, you can use that as your relationship. So we're going to keep it really simple to simple linear relationships like multiplying, dividing, adding, subtracting, but you can do other things if you have more complicated relationships between your sketch entities. As before, go back. My phone is ringing. Okay, I had to take that phone call, and it's been a little bit since I unpause it or pause it. So extrude your rectangle, and then go back and change the value of L several times, and just observe how all, like not just the length and the width of the rectangle, but also the extrusion will update along with it. And do that a couple times to get comfortable with it, because that is going to tie into what you will need to do for your screencast. Now, explore the parameters tables. In Fusion, this is under the Modify panel, and then you're going to select Change Parameters. If you can't find it, check out the video because I'll show you where it is on the screen. But this top one is from Fusion, and you can see like our dimension is L, and whenever I screen grabbed this, I had it at 10. Okay, that's just whatever it was at. And then you can see the dimensions that I put in here, like 2 times L over 3, and what that was sitting at, and opened up all the parameters. So take some time to go in and actually play with that. You can also go in and change your expressions, and you can watch the values in the table update when you change that. So that's another thing you can do. In Onshape, it's going to be on the far right of the screen. You're going to be looking for this. It's like the little X. Okay, and that's going to pull out in your Part Studio your variables. Now, this one does not show all your assigned parameters because the two programs are different. And so in Fusion, Fusion automatically assigns, like if you see there, it says like D3, D4, like it assigns the parameters to it. Onshape does not do that. So in Onshape, you will only see your L value and then whatever your current value is there. But you can also update the value over in the table, and then you'll have your prism over here to the left, and you'll be able to watch it update from there. So that's the in-class activity to kind of explore how those work. So what is your assignment? You are going to design an eccentric cam as follows. So we have a nice diagram there. Constrain the center of the large circle to the origin. Okay. Define the diameter of the large circle as D or pound D if you're in Onshape, and set the initial value to 2. Okay. So same way you would have done it for your prism with that initial dimension. You're going to set the initial dimension to 2, and then define the diameter of the small circle as 1/8 of your D value. Okay, so you can do like 1 times D over 8, or like just D over 8. And then define the distance between the centers of the holes. I guess those are circles. I don't know why I typed holes there. As D minus some kind of question mark. Well, I will give you a number that's unique to you. Okay, so you're going to say like D minus 3 or D minus 4. Well, you can't because your original D value is 2. But all right. And that's so you cannot copy off of others for your screencast. So that's like a cheating prevention measure that you're going to have different numbers in there for each of you. And then extrude your cam to a value of D over 4. So most of you are going to have, like, most of the elements of the design are going to be the same except for whatever number you have there. All right. Now you're going to create your screencast. So practice with the design before you screencast it so that you're sure that things are going to work. Make sure that you can go in and change the values, or that you have the tables pulled up and you know what's going to happen. So take a few minutes and practice with that. Record a screencast that shows your model updating as you change the value of D. So change the value of D from 2 up to 3, then change it from 3 down to 1 to show the updates. Open the table to show where the variable is listed, and you do have the flexibility with your screencast to open the table first and have it open side by side with your design to change the values from there. Either way is fine, whatever you think is going to demonstrate it. Keep your screencast to at most a minute 30 seconds. If by any chance it runs longer than 2 minutes, I want you to redo it. Okay. If you end up between 1 minute 30 seconds and 2 minutes, try not to do that. But if you can't figure out how to stop it, it runs longer than 2 minutes, I want you to actually redo your screencast, okay? Because I can't watch that many videos. So that is what you will be doing for your screencast. Remember, the goal of this lesson is to demonstrate that you understand how parametric modeling works and that you can do it and demonstrate it in this particular lesson. So that's what you want your screencast to show. Okay, if you have any questions, as always, please let me know.